Hello, everyone. Hey, everyone is really tired. It's awesome to see that many people here actually attending and looking at how to build good architecture for Windows 8 applications. And on top of that, you're all apparently perfect, brilliant developers. Because yesterday I was down in the Microsoft Solution Experience thingy and talked about Windows 8 development. There's like 4 people coming around, and they were asking about Azure. So apparently you have no questions, but I'll try to sort of give you some information anyway. What time of day yesterday? It was... Oh, that would be the entire day. So everyone was in line for Surfaces the entire day, and they still are. It's amazing. I got mine on Sunday. That was a lucky thing. So the talk is about building MVVM-based architecture that works. And it's about... So, OK, first of all, it's XAML C#. So if you're JavaScript, HTML, building your Windows applications, I am really sorry, this will not work for you. So if you are, switch to XAML C#. That's awesome. So who's that guy? My name is Chris Klug. I work as a... I think my title is senior consultant or senior software developer or something like that. I prefer to call myself like technical dude because I do basically everything at my work. I do everything from working in Photoshop and doing design all the way to Azure backends and stuff like that. As long as it's Microsoft-based, I'm game for it. I have a pretty extensive background in doing Microsoft technology, and I've also managed to accrue a cool MVP. I am a Silverlight MVP. That is awesome. Not many left. Most of them have left, but I'm still fighting. I still believe in the future for Silverlight. And I've been working a lot with the whole idea of how can we get XAML C#-based applications or store apps or Silverlight apps and WPF apps to work in a structured way. What patterns can we use, and how can we build things that actually makes our development process faster and simpler and easier and repeatable? How can we build something that we can sort of package and reuse? And on top of that, I'm actually doing another talk on Thursday about how we can get this pattern to work together with the designers, how we can get developers doing MVVM and doing all of the code and all of the architecture and all of that stuff that we're great at, while the designers do their stuff, and then we can just marry it all up, and we get something that looks good and works. So if you're interested in that, Thursday is sometime afternoon, I think. So, yeah, this talk is all about what's in my head. That's a kind of a scary place to be, trust me. I've been there. I am there quite often. This talk is about what I've learned doing XAML C#-based applications since basically Silverlight 2 alpha release or something like that. And going through the paces and looking at what works, what doesn't work. And I've come up with my way of working with things, and I'm trying to put that down now. I'm trying to get it into a framework. Unfortunately, Microsoft released Prism, which is pretty much identical to what I came up with. So what you'll see here, which is my thoughts, you can take all of that stuff and you can just walk over and you pick up Prism, and Prism will be a good foundation for you moving forward with the ideas that I've got as well. But my talk is all about what I've come up with, my knowledge from previous projects and all of that. So if you don't think I'm right, then go ahead and don't think I'm right. Just go home and try it, and you'll see that I am. So I do not speak Japanese whatsoever. I am from Sweden, by the way. So if you don't hear and understand what I'm saying, tough. I'm going to show these characters. It's basically Shu-Ha-Ri. This was shown to me by a man called Alistair Coburn, who works a lot with agile methodology. I'm not a very agile person, and I'm not a big methodology fan, but he showed this, and it actually made quite a lot of sense. It's about how you learn things. It comes from Japanese martial arts. So it's actually the three phases you go through while learning stuff. You got the Shu phase, where you just repeat after your master. Your master shows you exactly what to do. You repeat it, and that's it, until you know how to do it perfectly. No questions, no nothing. No asking, can I do it differently? Can I do it better? You just trust your master, and you copy your master. Your master, in this case, apparently being me. That's awesome. Ha is the next phase. After you've conquered that phase and you know exactly how your master wants you to do it, and you do it precisely like him, you go one step further. You start looking at other masters out there. What can they teach you? How did they do it? What other ways are there of doing that same thing? And once you've gone beyond that, you go into the re-phase. The re-phase is when you basically you know the basics, you know what options are there, and you transcend it. You just go, okay, I don't care. I'm not going to just rehash what everyone else is doing. I will actually make up my own way of doing it. That is my interpretation of it. I actually Googled it today. There's a good explanation on Alistair Coburn's wiki, I think, and there's one on Martin Fowler's. So there's a lot of information about it out there. So to put it into developer words, who of you has seen The Matrix? Arms up. Okay, let's take it out. Anyone not seen The Matrix? Okay, there's no hands up. This is basically Neo, okay? Neo wakes up, he gets plugged into this little machine, and they download all of that martial arts stuff into his brain. That's the shoe phase. Basically, he just copies, he learns this is the way to do it. Then he starts fighting Morpheus. And then he basically takes that and he takes it one step further. He starts looking at different ways of doing the same thing. And then finally, he becomes the one and everything turns green and he can fly and all of that. And that's the re-phase. So that's what you're heading for. So I went into Google and I went, architecture is. And I looked at what I got up. I was actually about to do more. But I just wrote that. And I found it funny that architecture is dead was the first thing up there. Kind of ruined my talk. So and then I kept writing, and then due to Google's adaptive search thingy, I can't actually get this up again. So I had to find someone else's computer and search it again, so I got that answer back, because that's the neutral answer that you get if you're in Sweden, apparently. And I really disagree. I think architecture is more the differentiator. Architecture is the thing that differentiates just an application that works, an application that you can build, that will run, that will work, hopefully, and an application that you write that works, that feels good, that can be extended and can be, first and foremost, maintained. So how many of you think about maintainability when you build your applications? Like, straight up, honestly. Yeah, so half of you are lying. Because I know that half of you go and you sit down with your computer with this brilliant idea and you start going, and there is no thought about, oh, in 10 years I'm going to have to maintain this as well. I've got all these old VB applications. No, you don't. Honestly, we don't. Developers generally don't. Developers have this brilliant idea and they start chugging on their keyboard and they build it. And most of the time, that doesn't become maintainable. It doesn't become code that you can actually run through, extend, and work on. It generally results in a version 1 that you have to throw out. And then version 2, you can reuse some of the concept, but you go back and you pretty much rewrite a lot of it. And when you start looking at architecture, you have to either simplify development or maintenance. Anyone disagreeing with me? Yeah, this is the guy up on the podium. He's about 6'4", big, and he goes, anyone disagreeing? Yeah. No, the thing is, it's actually fairly easy when you start looking at architecture and looking at patterns and looking at all the stuff that I've been doing the last couple of years of looking at MVVM and dependency injection and the solid principles, all of that, it becomes this really, really weird development cycle. It becomes complicated. It's like you go into your code and there's like an interface. Okay, so I need to find the implementation of that interface. And I'm like, okay, there are 3 of those. And then that thing uses another interface, and I need to go and find the implementation of that. And it just becomes layer after layer after layer after layer of just trying to find what is really happening. And on top of that, if you build it the right way, you actually end up with like 1 billion different implementations of this same interface. So you don't actually know until runtime how your application is actually put together and how it works, because there can be different ways of doing it. Anyone using MEF, or what used to be called MEF? Yeah. MEF. MEF is good. Okay. So the thing is, with meth, which I've been doing a bit of, it makes it even more complicated because there's no actual way for you to see declaratively, this is the way my application will work when it's built, because there's no way where it tells you that this interface will be implemented by this method. It's all just magic. It just weaves together. So all of these layers of abstractions are great for maintainability and maintenance, but they suck from a development point of view because it makes it really hard to follow your code. So it's always a matter of finding this fine line of getting enough abstraction in there to make it maintainable, but not so much that it becomes really hard to understand what your application does. So if we start looking at XAML C# applications or XAML C++ applications, the out-of-the-box approach, which you see Microsoft doing in all of their basic demos and the projects you get with Visual Studio, they basically write their UI in XAML, and then they write all of their application logic in their code behind. Not a whole lot of abstraction in that. They might say it's kind of UI and application logic very abstracted away because they're two different files. Two different files is not the same thing as abstraction in my world. There are other ways of doing it. And it also makes it really hard to change the logic, change the way your application works, because you basically screwed into the fact that views have to be shown in a certain way for them to work together and all of that. So they started introducing MVVM, and they said, OK, so we've got the view with all the XAML. We've got a model, which is the data that we need to show. Let's put another class in there, the view model, which basically takes whatever information is in the model, adapts that to the view, and let the view work against the view model. OK, that's kind of sweet. And on top of that, they decided that the view model and the view has no knowledge of each other at all if you do it correctly. So the only thing you need to know is basically some string versions of the names of properties on your view model. That's it. So that's a nice pattern. I've been using it extensively for years, and it works well. The only problem is that it doesn't quite cover all of it. I actually want another layer in there. Now we're looking at adding more layers. This is getting a little bit complicated, but this is about as much as I put in there by default. You add another service layer in there, so you don't let your view model go straight and create your models and all of that. You basically add a services layer or a service layer that your view model is dependent on, and then you can switch out all of that functionality. Make sense? On top of that, it makes it possible for us to split out and actually let our view model consume and use the model, but also platform-specific functionality. So when we're looking at going up, I know the talk as such is about Windows. It's on the Windows track, and it's all about store apps. But it's actually interesting to have a look at how can we get this thing to work across the Microsoft platforms. How can we get our applications with this pattern to work in store apps, in WPF, in Silverlight, and on phone. And it's actually possible to do. But we have to make sure that we put that service layer in there that puts an abstraction on top of anything that's platform-specific, because they all work in different ways. So how many of you have tried working with a portable class library? OK, so 2/3 of you said, I think about maintainability when I start working on my application straight away. And when I ask about portable class library, it's like 1 or 2 hands going like, OK, is there anyone in here that does not know what a portable class library is? Sweet, there are a few. I'll explain. Portable class libraries are basically a project type in Visual Studio that makes it possible for you to build assemblies that can be consumed across a lot of Microsoft platforms. So you can write code that will run on in-store apps, in Silverlight, in Windows Phone, and on WPF, and on Xbox, I think, in one swoop. And what they do is they basically take all of the common parts that we've got in those different frameworks, and they limit so that you can only use those parts. That is brilliant for a lot of reasons. But mostly it's brilliant because we can write code once, and we can then use that across all those platforms and give us that functionality that we need all across the platform without having to rewrite it. There's another way as well that I really like. Have you tried the add as link in Visual Studio? You can basically create 2 solution files, or 2 projects in the same solution. And you can have one target one platform, one target another platform. write the code in one of those projects, and then say, in the other project, say, add existing item, point towards the class file in the other project and say, add as link, which means that you actually get the same C# file in both projects, so you only have one instance of it, but then you can add compiler things in there to say, if on this platform, do this, if on this platform, do that, and you can basically replace those small things that might not work on both platforms. So there are two ways of doing it, but portable class library is by far the easiest way of doing it. And if we take that view I had of what will turn into MVVMS, whatever, I'm not going to add more letters to that acronym. But if we look at the MVVM version that I like to have with the service layer in there, and we start looking at what parts can we put into the different assemblies, we'll look at view, very platform specific. We cannot take a view from Windows 8 and put it into Windows Phone. Why? Well, there are two fairly big reasons. Number one, XAML in Windows 8 is not same as XAML in Windows Phone or any other platform. So all the XAML implementations are actually just a little bit different, so you can't just move them across. Number two, a view that's designed for a tablet or a full screen on a laptop or like a stationary computer will not work very well on a phone. So from a UI perspective, they should not be the same, even if they could. They should be different. And no, you cannot just take a big view and scale it down, because you're still using fingers. Just saying. You can get like a pencil sharpener and get all your users to basically sharpen their fingers so they can point at really small things, but it's not going to work. So the views have to be platform specific. They have to be aimed at that specific platform that you are targeting. However, the view model and parts of the service layer can be portable class library, and should be. So the reason for putting that part into portable class library is that we can have a lot of that functionality reusable and come across all of the platforms. And on top of that, putting it into portable class library makes it really easy to test, for example. So you can pull that up and run any other C# test runner that you want to, which can be hard if you put it into one of the other project types. So when I circle this services stuff and say portable class library, that will be your interfaces. You put your interfaces into portable class libraries, saying that this is the definition of it, but then you take the actual implementation and make it platform specific for obvious reasons. But that means that my view models are only dependent on service interfaces, which means that it doesn't really care if they're coming out of Windows 8 or out of phone or whatever. And another neat feature of that, which I really think is good, is that my view models, being portable class libraries, cannot have any form of implementation that's platform specific. So if you end up saying that, oh, I can't write this in my view model, then you're doing it wrong. Anything that you can't write in your view model in here shouldn't be there, because in that case, it's platform specific and should be abstracted away. So in about an hour and a half, when you've thought about that, you'll come back to me and you hit me and you say, that's not true, because in this very specific scenario, yes, there are cases when that statement is a little bit too bold, but it does give you a hard line, basically, that you have to consider every time you hit it. And we all like, as developers, we really all like being forced into doing things, right? It's the whole thing. It's like, how many of you are doing TDD? Ooh. Cool. If you ask that question in Sweden, it's like 2/3 of the crowd. And me saying I don't like TDD, it's like they're going to kill me. So it's nothing bad with TDD, but TDD is, I think, liked for a little bit of that reason. It forces you into good practices. It forces you into building software in a very specific way for TDD to work. And apparently, once again, developers like to be forced into doing the right thing. And then finally, the last thing I got down there is the portable class library, the model stuff. So the model is often something very simple, a simple data transfer object or whatever coming from some service call or whatever over the wire. So that can be put into portable class libraries because it's just a simple, dumb DTO in most cases. And once again, that also means that it can be used across the different platforms. So if you're doing web service calls or web API calls and you get JSON back, the implementation of calling the service and deserializing the JSON is going to be platform specific, but the object coming out in the other end is going to be platform agnostic. So when you start looking at that, you start going, oh, I need a framework. So first of all, yeah, how many of you are doing MVVM-based work today? Okay, leave hands up. How many of you are using a framework today? The funny thing, there were more hands coming up asking about the framework than asking about doing MVVM. That's kind of odd. Okay, so frameworks are good for a lot of reasons. There are a bunch of them out there. I think the most common ones would be MVVM Lite, Caliburn Micro, Prism. There are a few others. I've got my own. But the thing is, you have to consider, is that the way I want to go? There are downsides to frameworks as well. So if you go with a framework, remember that you're also depending on that framework being updated in the same time frame as you want it to be updated. If you work with Phone, well, Phone is, well, I happen to use Phone because I had a friend who went down and used the framework for one of his clients, and then they updated Windows Phone. They wanted to go to Windows Phone 8, and it took about 2 months before the MVVM framework that he used was updated. And for that time, they can't update the product. So using frameworks is not all just as silver bullets, like this is the awesome way to do it. You are actually putting a lot of trust into that framework, first of all, being continually developed, because most of these frameworks, if not all of them, are open source. Nobody is actually promising you that they will keep working on them. And you're also basically trusting them to update them in time and quickly. Most of the time, yes, if you look at Caliburn Micro, if you look at MVVM Lite had a freaking beta version of their version for Windows 8 done within, I think, 8 hours of the preview being released for Windows 8. So yes, Luron is very fast, but not all of them are. And on top of that, going plain vanilla, just skipping frameworks, just doing your own thing and building whatever you need can actually be quite neat. I have a friend who does pretty much only Windows Phone and Windows 8 development at the moment in Sweden. That's all he does. He started out doing frameworks, and he's moved away from it. He doesn't have a framework at all. He hasn't even started building his own, which is what I would have done. Well, actually, I have done. I spend more time building my framework than I do building applications, which is kind of stupid. Yeah. So the whole BYO framework, don't. Just don't. Like, honestly, don't. It's just stupid, because you end up with, like me, I have no applications in the store, and I have a framework. It's a really good framework. It is. However, it's also not open source. It's not available anywhere, so no one else can use it. It would have been neat if I actually open sourced it and put it out there so other people could use it and put it into the store. I now have a framework and no store applications. It will be there someday. But start thinking about how you want to do it. Don't just go, I'm going to do MVVM. I have to get MVVM Lite. I have to get Caliburn Micro. Have a look at what will it give you, and have a look at if it might be easier for you not getting it. And also, if you start looking at frameworks, have any of you ever seen a framework that was built to be replaceable? None? Yeah, there's an obvious reason for that. But the thing is that it also means that you get all of that stuff from that framework into your application. There's no easy way for you to come down the line and go, oops, that framework just doesn't cut it anymore. I'll just replace that with something else. It doesn't work like that. So once you choose a framework, be very, very sure that that framework does what you want it to. Most of them are open source, so you can just rewrite it if you want to. Isn't that the way open source works? You get something that should do what you want, it doesn't, so you rebuild it yourself and you fork it, and yeah. So there are a couple of principles that I've looked into when it comes to MVVM that I find the most important ones. There are a lot of stuff that I change and move around and everything, but there are a few of them that I go, I have to have this in my application. You're all sitting there thinking, yeah, he needs them. I don't really give a, yeah. Dependency inversion, guys. it should be there in all applications. You should separate everything out. You should get dependency inversion. You should make sure that you can switch things out. Why? Well, there are a lot of reasons for it. One of the reasons could be what I'm doing in my talk on Thursday. I am building, at that talk, a Twitter client. And somebody told me that I should not be reliant on a network connection at the conference. Yes, a Twitter client without internet connection. It's going to be an awesome talk. No, the thing is, based on that, I could just go in. I define my Twitter interface. I can build my Twitter integration against the web version. But for the talk, I'll just skip that and do hard-coded files on disk instead. I can put in some thread.sleep to sort of simulate network latency and all of that. If I hadn't told you, no one would have known. I would have shown off the application. Everyone would have gone, cool. Twitter must be down. There are like 2 tweets in his feed. But other than that, it's a good way of just replacing things. And once in a while, you actually end up in a situation where you don't have internet connection, where you have to work without it. And in that case, you need to take out whatever is network dependent and do something else. Or for testing. If you do like writing testable code or testing all of the stuff, you're building unit tests, you need to be able to remove all of those dependencies for your tests. So dependency inversion is my #1 thing. And there are a couple of options for it. And I'm actually going to bring out code. Woo! I'm not going to code anything. I'm going to show you pre-made code to show some ideas. But there are a couple of different options for dependency injection or dependency inversion. You got singletons. We have factory objects. We have service locator and dependency injection. They're all valid ways of doing things. They're all ways that you can do it if you write it the right way. So if I try to have a look at the different ways of doing it, my computer died. We'll just have a quick look at the different options. Sweet. So this solution will be on my blog later on today, so you can download and have a look around if you want to, and probably kill me for it not working properly in some cases. But it basically shows off an idea. It's not a pre-built massive solution. It's just some ideas that I have. So if you start looking at dependency inversion, we start looking at my services. I just got a very simple service here called iIsItHoliday service. It's a tweak on the iIsItFriday service that I normally use. So if we want to look at that, there are a couple of ways of doing it, as I said. If we go into our view models here, the simplest way of doing it is using a singleton. Singletons are sweet. They're very easy to use. We just go isItHolidayService.instance.isItHoliday, and we get an answer back. That is sweet. But the important thing here is that isItHolidayService is an abstract base class. This does not have the implementation. What it exposes is an iIsItHoliday service. Once again, I keep coming back to services being interfaces, nothing else. But if you do it this way, it's really easy to get a hold of. And you got that inversion of control, and you can basically say, sweet, I want to test this, I'll switch out this thing and give other answers back. If we look at the way it's set up, it's actually not that complicated. It basically just has an abstract class that has an instance property which is static, which is protected. So I inherit this class. By inheriting it, I get iIsItHolidayService. I add the implementation, and then I set instance equals to this when I'm done with it. So singletons are okay, even though a lot of people say you should not use a bunch of static variables and all of that. You can use static if you do it in the right way, and if you use interfaces. The other way to do it is using factories. Factories are a little bit better, or interesting in a lot of cases, because you got, in this case, isItHoliday service factory.create. Create returns an iIsItHoliday service, just as you expect. The good thing with doing factories instead of singletons is that you can change the lifetime of the application or of the service. So in some cases, a singleton is good, you get state and all of that, but in some cases, you actually want to new it up every time you use it. And in some cases, you got these really freaky, weird situations when you need to have them thread-specific or message-specific or any other type of lifetime management. And in that case, the factory method can switch the way that you use them. And then we have another one, which is what I actually started out doing. I have a service locator, which is a class that exposes a service locator, but it then has a resolve method. Actually, that's not the one that I want. Sorry. Let's start with this one. Service locator, or simple service locator, .current, exposes a simple service locator, which has an is it holiday service property, which is an is it holiday service. So this is neat. It means that our simple service locator, if we look at it, has a property for each one of the services that we need. So instead of having to find out all of these different singleton objects or factory objects that we're using, we get them all in one place. So we can just go service locator .current or .instance or whatever, and then we can find all of the services that we need. So if you look around the web, there's a lot of people out there that saying using service locator is an anti-pattern. It gives everything access to everything, and it's not good, and all of a sudden view models can call services they're not supposed to call and all of that. Yeah. A tip from me, view models are not artificial intelligence. They do not call other services just because they think it's fun. They call other services if you tell them to. So yes, apparently it's an anti-pattern to save you from yourself. So I don't see the big problem. The only problem I'm seeing here is that if you've got a lot of services, and if you start abstracting away all of your web services that you're using and all of your platform-specific stuff and all of this and all of that, all of a sudden you maybe have like 100 different interfaces that you need. That service locator is going to be a little bit tricky. It's going to have 100 properties with all of the 100 services that you need. So the way to get away from that is to use a proper service locator, which has a resolve method instead. So the resolve method basically means that this service locator is resolving whatever you need using an IOC container. So instead of having specific properties for each one of my services, I go and tell it, I need one of these services. Can you please get me one of those in some way? It doesn't really care how. It just says resolve, fix it, do whatever you want. You can use unicorns and rainbows, just get me one. That makes it fairly cool because it means that we can go on and you can use an IOC container in the base class for this. And it also means that we can manage lifetime of our services using an IOC container. So we can get a bunch of functionality from something that someone else has built. And the less we have to type and the less we have to build, the better it is. And finally, dependency injection. Dependency injection is actually my preferred way of doing it. Because dependency injecting, instead of just inversing the dependencies, is you get it injected into your constructor. Or you can have property set as well. But in this case, I use the constructor one. It means that it's very easy when you open up a view model to see this view model is dependent on these services. And that's actually quite a good thing, knowing that, okay, so this thing uses this, instead of having to open up every single method in my view model to figure out that, oh, yeah, it's using the service locator in that method, and that method, and that method, and that method, and it's using these services. You get it all straight up here. There are a few tiny issues with it. First of all, it's not possible to do out of the box with XAML C#. You need to have another object in there, which I'll get back to. And the other one is, I get people at my office killing me for this, but they normally say you should not have too many interfaces coming into your constructor, because if you've got a bunch of services coming in, your class is doing too much. It's a God class. It should only have one purpose. Single responsibility is like the number one thing that every developer knows. If I start taking in like 50 services into my view model, I am doing something wrong. Okay, yeah, 50, I am probably doing something wrong. But view models often do a lot of things on the view. They often include functionality from a lot of different services because the view model is basically just serving up a view that needs a lot of functionality. So you do often end up with view models taking in a whole lot of services. That is okay in my world. You can split it down into sub-view models and things like that, but it makes it a little bit more complicated. So I said it couldn't be done out of the box, and it can't. Because normally when you set your view models in your views, it looks something like this. Maybe. There it is. Page data context, factory view model. The problem with that is that that is going to new up a class of a factory view model class, and there's no dependency injection going on. There's nothing responsible for newing it up except for the framework running it, and it has no idea of actually dependency injection whatsoever. So what you do is you create a separate class called a view model locator, which should be in here somewhere. Sort of there. So the view model locator is fairly simple. It's just a class that has a property for each type of view models that you want to use. And there are other ways of doing it. I'll get back to why there are properties for each one of them. And then it has a something in the style of resolver method, or you pass in an IOC container, whatever you want. One way of actually figuring out what views are there. And then that class is responsible for newing up your view models, and it is responsible for doing the dependency injection. That view model locator is then put into app.xaml here as a managed resource in the resource dictionary, which makes it available to the entire application as a static resource. In the code for this thing, in the code for app, you see that I new up a IOC container, in this case, tiny IOC. I set the service that I want to use, Swedish holiday service, obviously. I pull out the view model locator from the resources, and then I say your resolve method is the one that's coming from the IOC container. By doing it like this, it means that we can set our data context like this instead. And this is a little bit weird to say in the first time, but you say data context equals data binding. I want to bind to the property called dependency injection view model on the static resource called view model locator. So what I'm doing is I'm basically data binding in my view model based on the view model locator, which can then do dependency injection for me and get everything running. The cool thing with this is if I'd built everything and everything was running and all of it, setting the data context, being the fact that it's in AppSaml, not AppSaml CS and done from code, Visual Studio and Blend will actually run AppSaml for you and compile it while you're in the designer, which means that when you go and say data context down in the properties pane and say, I want to data bind this, it will automatically say, oh, you got a view model locator. Which view model do you want? And you can graphically build up the entire data binding for your data context without it being a hassle to do. Might even try and do that just to make sure it works. Should always go off script, right? Someone told me that. Doing a presentation at a big conference, always do something new that you haven't tried before. But if we look at this, if I look at the page, if I go data bind, you'll see here that it has automatically found out that in the static resources, there is a view model locator. I want to bind to that view model type. It also means that we can maintain lifetime of our view models. So if you want a singleton view model that's only one for each application, you can let the view model locator just have a singleton version. If you want a new one for everyone and all of that, you can do that. So it gives you a lot of flexibility. So, was that right button? Yes, it was. Dependency inversion is my number one thing. I can't live without it. I'm not kidding. Building the tiniest little application, I throw that in there every single time because it's just easy to do. Once you have, in my case, a framework or a pattern for doing it, it takes about 5 minutes to get up and running. The other thing that I figured out is that we sometimes have to do view model to view communication. There are 3 ways of doing this. There is the good, the bad, and the ugly. Guess if I'm thinking of just using one of those. The thing is that there are things that we need to communicate from the view to the view model from code. Why? Well, there are certain things that you want to do in the view, in code behind, that just is much easier to do there. But then once you've done that and you got the response or whatever you're doing, or you're using some custom control or all of that, once you've got the result, you need to pass that up to the view model. And as I said, there are 3 ways of doing it. You can either tightly couple the whole thing and basically screw up doing MVVM. I will potentially hunt you down while you sleep like Freddy Krueger if you do it. But that's just the way I am. I'm a little bit, strange in that way. Second of all, you can use interfaces. So you can basically add an interface to your view model and let your view be dependent on that interface. That adds a bit of decoupling, adds another layer of abstraction in between. Or you can use bindings. So it's actually quite neat. We can do bindings from code to give us the same result. If you look over here into view model to view communication, look into the client, into the view. So there's 3 options here. You got the coupled communication, and that's quite neat. Something happens. In this case, I'm trying to do a save. I want to save something, and as I save, I need to pick a file. I need to go to the file system. I need to get the file system, the stream to the file and all of that. And all of that shouldn't be done in your view model. For the very simple reason that if you in your view model start going to the file system and looking for files and asking people to choose files and stuff like that, how do you unit test that? Oh, yeah. In this unit test, when I run this unit test, I got 400 of them. 64 times I have to choose a file. It's going to take a while to run through those unit tests. So what you want to do is you want to either abstract that away into a separate service that will handle it for you, or you can do it in the code behind. In this case, code behind is fine. I don't really care. I do this in one place. It took me 5 minutes to write this. It's going to take me 15 minutes to write an interface and do dependency injection and abstracting away stuff. Hey, 5 minutes is much better. So I do save click here. So what I do here is I basically take my data context, pull it out as my view model. Then I pull up a file save picker. I pull out a file. I open the stream. I save the file and send that up to the I put that out to the data context. So I do DC, here it is, data context.save. And my data context or my view model has a save method that takes a stream. And I send that up, and that's awesome. I have now removed all of the use of MVVM, because I am now telling my view that I can only use my view model. So that whole decoupling of view and view model, gone. Now you're stuck with never ever being able to switch out your view model. So the other way of doing it would be to have my view model implement an interface. Has a little bit more decoupling in there. So if we open up save here, I do pretty much the same thing, but instead I say data context as saving entity or whatever you want to call the interface. It has the same method. It has a save method, takes a stream, has a callback when it's done. But now, as long as my view model implements saving entity or whatever you want to call the interface, you can switch out the view model for that same view, and you can get the functionality back. And finally, that was the bad and the ugly in my world. We can do it much, much nicer. So the way that we sort of bind up our view model and our view is using data bindings, right? Why not use data bindings even though we're in code behind? Is there anything that tells us that we can only do binding in XAML? No. XAML is just writing code, but it's doing it declaratively instead of doing it with C#. So all the stuff that we can do in XAML, we can basically do in code as well. So instead of calling out my data context and everything, I can set up a dependency property. I hate saying that. I'm from Sweden, sorry. Dependency properties are the baseline for doing data bindings, right? So we need a dependency property to be able to data bind anything. So I create one called save command of type iCommand. iCommand is whatever we use when we want to move from the view, do some functionality, or actually execute some functionality in the view model. So I bind one of those, and in the constructor for my view, I say set binding, save command property, bind to save command. Sweet. We get a little iCommand property down here, which we get when we build dependency properties. In the save method, we go and we have a look. Is save command equals null? In that case, well, then I can't save it, so I just return. If it's not, then I pull out my file, I get my stream, and then I say save command.execute passing along the stream. I need no interface. All I need now is my view model having a property called, whatever I called it, save command of type iCommand. And then I have data binding doing the work for me, which makes my view just as decoupled from my view model as it would have been using data bindings in my XAML. So that is the way I prefer to do it. It's a little bit more code, but it just decouples everything nicely. I can't believe that I am on stage saying decoupling and abstractions and stuff. It's weird stuff. View model communication. So very often we end up in a situation where one view model needs to communicate with another view model. Because often we put several view models on the same screen. Even if we're doing Windows 8 applications or store applications where we just have one big screen, not different windows and different panes and all of that, we still end up in situations where we put in different view models. That's just the way it works. And we can communicate between these view models in a couple of different ways. Most commonly used would be using events. Having your view models expose events for whenever things happen, and then we subscribe to those events from other view models. Kind of means that view model A has to know about view model B to be able to listen to that event, right? It's really hard to hook up event handlers to something you don't know what it is. The other way is doing callbacks. Callbacks means that we can tell view A, or view model A can tell view model B that whenever something happens, call this code for me and execute this or give me a call back on this method. Same thing as with events. View model A has to know about view model B to be able to give it a callback. And then finally, the better version of doing it is using an event aggregator. So event aggregators are a pattern that Prism has built in. So all of this messaging stuff, being able to communicate from view model A to view model B, is just built into Prism in this way and just makes a whole lot of sense because it's a way for us to communicate between view model A and view model B without them knowing of each other at all. And it also means that when view model C comes into the picture, he can also go in and say, oh, by the way, I want to listen to that as well. And we can keep adding things. We can just go as many view models as you want and go, I want to listen to that, and I want to listen to this, and I want to listen to that. And it also means that we can do a whole bunch of really funky decoupled things with whenever something happens, we just send out an event in the event aggregator, and then somebody will handle that in some way. It's a really neat way of doing things. And once you've got an event aggregator, it's actually really, really simple to work with. So I have this view model to view model communication here. I have a class here. I have a class here called Event Aggregator. And I love the fact that I've now stood around here saying that you should have interfaces for everything, not take dependency on proper classes and all of it. And this doesn't have an interface. It should, I know. It should be abstracted away, but just to make it simple. The Event Aggregator is a singleton object. And it basically has, let's split it up a little bit so you can see it. It has 3 methods. Register for messages, which is a generic type, and it takes a callback. So basically, you go into that one and you say, sweet, I want to listen to messages of this type. And you give it a callback and say, this is where I want you to call back whenever something happens. And then you have an unregistered, register for messages gives you an iMessage registration back. It gives you some token to hold on to, so you can go back and say, by the way, that subscription I have for that message, can you just remove that because I don't want to listen anymore? So whenever a view or a view model goes out of view and is removed, you should go back to the event aggregator and say, by the way, I'm now gone. Can you please stop sending messages to me, or I'm not interested anymore. And also, there are a few little things in here that you have to keep in mind when building one of these. You need to use weak references to the view model so you don't keep them in memory, because this is a singleton object. If you keep registering things but forget to unregister them, you will basically keep every single view model that has, or every single class that has ever registered for an event in memory. Not a good thing. I am speaking from experience. It's not a good thing at all. You end up doing a bunch of memory profiling to figure out that you're stupid. And that's not what you want to figure out, trust me. The other thing would be send message. Send message is sweet because it just takes an object. So I can take whatever type of object, I'll pass it into send message saying, I want to send this message. Woohoo! Here it is. The event aggregator will basically take that message and look, oh, what type it is? Sweet. Do I have any guys that said that they want to listen to messages like this? Oh, yeah, that guy does. Here it is. And you're done. That's about as simple as it is. So you'll build up these objects, and in most cases, you will have what you call messages for obvious reasons. So it will be a send email message or a help message. You could be very, very easy to use this to implement a help function. Whenever you have something highlighted, you press F1. You'll handle that. You'll go to that thing and say, I want help. Here is what I want help about. And then the help whatever something will pop up and say, this is the information that you need, for example. So it's fairly simple. Using it is fairly simple. There are a bunch of other things involved in actually building this thing that makes it a little bit complicated. I'm not going to go into exactly how this is built, but as I said, Prism has it built in. There are a bunch of other versions of it online that you can use. It just makes for really simple code. So if we look at the view models using it, it's an email client. It's a really crappy email client, but it basically has an inbox. The inbox has a bunch of emails. So I have a view model for each one of my emails. So I expose that as an IEnumerable of email. The email view model, very simple little view model. It basically has a from email, subject, body, what you would expect from an email, and an I command called reply. Basically, I want to reply to this email. So if I were doing it using events, it would look something like this. Whenever somebody clicked reply, I would have to call on reply requested, which in turn would raise an event like this. So there's a bunch of event in here, and we have to hook up event handlers and everything to listen to whatever happens. If we do callbacks, the email class would look like this, or email view model. It would have a callback method that would be you would push into the constructor. And whenever somebody tried to reply to it, you would have to call that callback. And that callback would have to come from some parent view model that has once upon a time created this view model and all of that. So it's a little bit complicated. And once again, it also means that the parent view model has to know about this view model. You can't do really decoupled communication like this. There's no way to do callbacks and events unless you actually have view models that know about each other. But if we look at the one using the event aggregator, it has nothing like that. It has no callbacks. It just takes the model, which is an email. It has no events, nothing to hook up to. And in the method, whenever somebody clicks reply, you say event aggregator.current.send message, and we send a reply requested message passing along the email. It has no idea where that thing is going. None whatsoever. It just sends out a message hoping that somebody will pick it up or somebody won't. It doesn't really care. The email sender, the guy that's responsible for sending reply emails, he goes, sweet, I want to have, if I don't look into the callback one, I look into that thing. Author view model is called here for some reason. In the constructor for that thing, it says, I want to listen to reply requested messages. Whenever somebody sends one of those messages, I want to execute some code. I want to run this code. I get one of those messages, I pull out the email, I set the properties that I need for my client to work. And whenever I want to send the email, once again, I can just go and say, send message. So once again, I've actually decoupled not view model to view model communication. I've in this case even pulled it out to do view model to service communication. So I've decided that sending emails is not something that my view model should be doing. But instead of taking an ISMTP service or IEmail service or whatever as a dependency inversion, I can just go ahead and send an email message using this. And I say, OK, I want to send a message. Here's the information. Can someone pick that up and send it for me? And then you can have services in the background listening to these messages, picking up, send email messages, and basically go ahead and send SMTP emails away or whatever it needs to do to send emails. So the event aggregator doesn't only have to be view model to view model communication. It can be general communication within your application as a bigger picture. No. I spelled that wrong, I know. Sorry. It's apparently called asynchronicity. Sorry. So everything should be asynchronous, right? Just look at the APIs in Windows 8. Everything is async. There's async everywhere. Anything that can take, I think the deal is everything that can take more than 50 milliseconds, potentially in some weird universe, should be async. And we have to make sure that all of the stuff that we're building can handle asynchronous operations. And you have two ways of doing it. Actually, you probably have more, but the two common ways of doing it is using actions and callbacks and using async await. So the new version of doing it is obviously async await using tasks, which is a very, very sweet and flexible way of doing things. We just go await. We adorn our method with async. We go await, and we can just write everything as it was synchronous, but we'll get all of the asynchronicity, that was one, on the fly. It's just C# will handle it for us. However, there are a few problems with it. It doesn't work in portable class library. So having said that you should put all of your service interfaces into portable class libraries because they should be platform agnostic, you can't use tasks because tasks are not in there. Luckily, Microsoft has built a package called Microsoft BCL.async, which you can NuGet. And you can pull that into your portable class library, and you get all of the task definitions and everything into portable class libraries as well. So all of a sudden, you can put tasks into portable class libraries as well. Just remember one thing. It took me a while to figure out. I'm a little bit slow once in a while. If you do it, you have to tell portable class libraries that you want to do Windows Phone 7.1 or later or whatever it is, one of those versions. If you go Windows Phone 7, it won't be available because they couldn't put it into that, so you have to go one version later than that. But, as I said, you have the async await, which is very, very flexible, but actions and callbacks should not be underestimated. Because first of all, you can actually do funcs and actually take parameters in and all, and you can have actions taking multiple parameters to the result. So normally, actually, until very, very recently, or actually I still do, I often use callbacks in all of my services. Because it just makes for a very easy programming model. If we look at our asynchronicity things here, look at portable, look at the calculator service. So these are the two ways of doing it. We expose iCalculator service task-based with a task of int calculate some heavy stuff. And then we have the other one, which is the callback version, which is calculate some heavy stuff, and it takes an action. That action has two parameters coming back. It basically has the int, which is the response, but also an exception. So by adding two properties in our callback, it's very, very easy for us to make sure that we get exception handling as well. In the callback, we can basically just go and look. If the second parameter is null, then perfectly. There was no exceptions. If it's not, oops, something happened. It's built in there. Using it, well, looks pretty much like you'd expect it to. Where are my, there are my view models. So if we look at simple callback, looks like that. Calculator service callback, do some heavy stuff, listen to the result with a result and exception. If exception is not null, something went wrong. And when something goes wrong, we always just do return. That's the simplest way of handling exceptions, right? Should never do anything else. It just makes it very, very simple. To be perfectly honest, I don't know how many clients or applications I've built where, at least in the first phase, then they've left my desk, they still have a little curly brace before this, and then it says // to do something, and then return and end curly brace. Don't order code from me. It's not going to work. So it's actually fairly simple to use. And it also means that it's easy to see if you do several asynchronous calls, because you just go further and further and further in. You just go one step in, one step in. So whenever this is done, I can do another call, and I can do another call, and I can do another call. And slowly you get this like levels of how many calls you've made. It's apparently, according to Scott Hanselman, it's called the arrow of doom. It goes out like that, and then it fails somewhere down here. And then it goes up, and you have to handle that. The other way of doing it is using the task stuff. And that in this case, it's just so simple. Await. You want to handle exceptions? Yeah, try catch. That's about it. But there are things that make it actually a little bit easier to use callbacks. How about progression? If we don't want to do something that has a callback or wants to notify progression when something has happened. Very, very simple thing, or it's a common thing. It's like, I want to do this thing, but I want to know how far it's gone, so I can have a little progress bar or whatever, notify the user that it's now gone 50%, 60%, whatever. That becomes a little bit complicated. In callbacks, it's awesome. Very, very simple. It just has two different callbacks, a progress callback and a completed callback. Progress callback takes an int, telling you how many percent is done, and the complete one takes the result and the exception. So it works the same. And with callbacks, it's quite neat, because you can actually call the same callback however many times you want to, passing different parameters. You can do whatever you want. So it's very, very flexible. When you come to task-based stuff, it gets a little bit more complicated, because all of a sudden, the task won't handle it. You can't just go async, await with progress indication thingy-majig, send it here. Probably could have. I'm not sure that Anders Heilsberg would have liked my thingy-majig thing in there, but it probably could have been done, but it's not there. So instead, you have to pass in. There's a new interface called iProgress. It takes an int. It's a very simple interface. And when you use it, so if we first look at the callback thing, that's simple to use. We do progressive work. When progress changes, do this. When it's done, do this. Very, very simple. For tasks, it actually means doing a little bit more work. We have to have a class that implements iProgress, which basically just has one method called report. Takes an int, in this case, because it's iProgress int. And that means that the task can then get that thing and report progress using that class. But it means that we have to pass in one of those when doing our work. So we're going to have to create a progress reporter class. And in this case, it uses a callback to change the value. And then whenever we call the method, we have to pass one of those in. So it's neat in the way that we pull the progress reporting out to a separate class. But it does mean that we have to create a separate class. We have to implement either this interface or some other interface, whereas callbacks is actually just very, very simple to use. But there are pros and cons to all of it. But however you do it, please make sure that you do make it asynchronous, because it should be. You should not lock up UIs. How many of you use Visual Studio 2012? They have got the whole thing down with Visual Studio 2012. I'm never going to get invited back to this conference, I know. But instead of locking up the UI, they push up a little prompt saying, doing background work. Still won't let me keep working. I am sorry. I get that there's more than likely a reason for it, but try to find a way around it, because that freaking thing is killing me. To be perfectly honest, I might as well have a locked up UI. To me, it's no big difference. So try to find a way where you can handle asynchronous stuff in a slightly better way where the user can keep going. Which kind of pulls me into platform abstractions. There are a few things that is reoccurring when I build my applications, which is basically some things are needed in all applications I build, and they are platform specific. So I have pre-built code that I can just pull in and get to work. Being actually the whole thing of doing asynchronous stuff with notifications and pop-ups and things like that when stuff is done, that is one of those things. I always have an notification service that can do stuff like that can do message boxes if I need that, or it can do toast notifications and stuff like that, because all of that is platform-specific and should be abstracted away. But I haven't actually chosen that service as one of those I want to show. I have instead chosen navigation service, dispatcher, and application. Let's start in the dispatcher end. Anything that's SAML C# based has a dispatcher. In Silverlight, it's called dispatcher. In .pf, I can't even remember it's called. In Windows 8, it's called the core dispatcher. It's all there. It's available as dispatcher on the page as well. It means that anything that goes on a different thread has to be marshaled back to the original UI thread to make any UI changes. Very, very important. And doing with tasks and all that, it's neat, because once in a while you end up on wrong threads, even if you don't want to and all that. So it's actually good to have a reference to that dispatcher and be able to marshal it back and forth. The only thing is that the dispatcher is based on, or is available through the page. It's not available, or actually in Silverlight I know it is. I think it might actually be in Windows 8 as well. There's a package.dispatcher or something like that. But the thing is, you don't want to call to that straight away from your view models. First of all, because it's not available in portable class libraries. And if it's not available in portable class libraries, it shouldn't be in your view model. Very simple, with limitations. But because it's platform specific, you reach it in different ways. That marshalling is different on different platforms. So you need to get some form of dispatch service. And there are a couple of ways of doing that. There's the way I used to do it, and there's the way I do it nowadays. So if we go into portable here, no, go into this thing, dispatching. I have two of them. So we've got dispatch service. iDispatch service, you register that when the application starts up, because the application will always start up on your UI thread. So when the application code runs, the startup code for your application, that will be the UI thread. You will have access to the dispatcher through the frame that's being created when the application starts up. So you pull out the core dispatcher, you push that into the dispatch service, and then you inject that into all of the view models that need it. And then you do dispatcher.runAsync to execute anything. The other way to do it is actually a little bit cleaner. Because the dispatcher is an abstraction of a synchronization context. And the synchronization context is actually a wide-known thing available on pretty much all platforms as far as I know. And that's available through synchronization context.current. So as long as I create this class, the thread marshalling service, on the UI thread, I can just go and say synchronization context.current. I will get a synchronization context for that current thread. And then I can use that context to do all of the marshalling. I don't need the dispatcher. I can do it manually using this instead. And this will flow across all of the platforms that Microsoft are using. So it's fairly simple. There is another way of doing it. Yeah, I'll just cover that quickly. Since the synchronization context can be used in this way, and is always available from the UI thread, if you're using view models, the view model will always be created on the UI thread. Either if you're using view model locators or doing it manually, it will always be there. So one way would be to have a base view model base class in which you do that. You get the synchronization context when the view model is being created. And then the base class for all of your view models will have a invoke on UI thread or whatever that does that for you. So you don't necessarily actually kind of need iDispatch service. So if you want to get away from one thing being injected into it, you can do it. And it shouldn't cause any problems doing testing either, because it should just keep working in test environments, but I haven't actually tested it. The other thing, I don't need that one anymore. The other thing I got is the navigation service. All XAML-based applications navigate in the same way, more or less. They do frame-based navigation. So basically, they work through pages like a web, whatever. You navigate back and forth between pages. They work the same, but they are coded a little bit differently. So if we compare Windows Phone to Windows 8, Windows Phone will navigate to a URI. You will tell it, this is the URI of my SAML file, and then it will basically, through that URI, figure out where the SAML is, load that up, and give you, or navigate to that. Windows 8, not so much. Windows 8 navigates to types. So you go navigation service.navigate to or go to or whatever it's called, and you give it a type. So they're a little bit different, but they work in the same way. And if they work in the same way and have the same idea behind them, there's no reason for us not to be able to abstract away a lot of that stuff. And also, the navigation service is available through the page. Once again, the base class for all pages have access to navigation service, but our view models doesn't. So we have to wrap all of that functionality into something that we can get into our view models. If we jump back into this thing, have a look at my implementation of navigation. Let's just go to this and this. So the basic iNavigation service just has a goto string with a dictionary being able to pass objects between views, not just being able to pass query strings like Microsoft's platform has by default, and then go back and can go back. Those are basically the basic navigation that we need for an application. As simple as possible. Then there's one more interface in here called iConfigurable Navigation Service, which inherits from iNavigation Service, which has a way of registering views. So the view models will be happy-go-lucky saying, I want to navigate to a string. I want to navigate to, and then my view or home or whatever you name your view. You give it a key. And then the service will figure out how to do the navigation. So for Windows 8, the implementation of register view is the key and the type of view to use. So I go to home, and it goes, the home key through a dictionary is connected to the main view model. Sweet, I'll give him a main view model, or I'll navigate to that. While if I did the same implementation on Windows Phone, it will have to be string, or string URI. So the interface will change a little bit for this part, which we can do through add link and stuff like that. But the view models don't care, because the view models will only use the iNavigation service interface, which has a goto string. So all of a sudden, we have got the same navigation paradigm for the view models, but they're still working on the different platforms that we're working with. Make sense? I stick to the interfaces for the very simple reason that the code for the actual service is actually a little bit complicated. It has a bunch of stuff in there, and on top of that, this thing is not the final version. It's a simple implementation of it that you should take and extend if you want to use it. And finally, application. How many of you have built Windows Store applications? Okay, there are 4 or 5 of you. How many of you can explain to me the startup procedure of a Windows Store application with suspend, resume, terminate, shut down by user, and when to do what in the application? There's one hand coming up. Oh, yeah, so evangelist at Microsoft, that does not quite count. You're disqualified. It is actually quite complicated. It's not something you just go, hey, that's obvious. No, you go, okay, in this scenario, this method is called, but it's called with a parameter that defines the previous state of the application. And if the previous state was shut down by user, it is restarted. Otherwise, it should be this, and it might be still in memory. And if it's not, was any of Brian Noy's presentation earlier today? Yeah, he showed off a graph of how the arrows work in the different states. Yeah, no. I am sorry, what Prism has done in or the PMP team has done with Prism should have been into Windows Store applications straight up. I don't believe they should have released the way it works now. So what you want to do is you want to go ahead and you want to grab Prism, because Prism will abstract away all of that for you. So I have a very Prism-like implementation here that basically handles suspension and activation and application lifetime stuff, and then basically rolls that down into simple, overridable methods that the user who goes in and builds a Windows Store application can understand. There is a on launch, sweet, starting from scratch. On deactivate, oh sweet, it is being deactivated. I actually spelled that right. On suspend, sweet, is being suspended, and so on. There are simple states that you can implement. And I'm not saying that this is a good implementation that I've done. It is just one of abstracting away complicated stuff. This will not go cross-platform in any way whatsoever, but once in a while, it's actually a good idea to abstract away complicated stuff from the platform so that when you build your applications, you pull this base class into all of your Windows Store applications, and you have a way of figuring out what to do. On top of that, this thing has some ideas that I want to put into my own framework, which will be released someday, where it basically means you don't have to do anything. There are a couple of abstract things here, like default type, like the main view type. What type of page do you want to navigate to first? Whenever you inherit this class, you're responsible for giving me that. That's it. The rest of it is just handled by the system. So if we look at the way this works, it means that my class is actually, my application is down to this. It is down to just, okay, if I remove that and that line, you actually don't need any of that because that's if you want to do search, if you want to have search charm enabled. All you need to do is basically inherit the class and implement main view type, and you're done. If you put abstractions like that in there, it's going to be so much easier for you to build your applications. I'm pretty much spot on time, I think. So if there are any questions, I will be around to answer anything that you might want to know. If you want to get in contact with me, there is my email address. I will answer as soon as I possibly can. I'm on Twitter. There's a blog where I do a lot. If you go back a while in my blog, there's a lot of stuff covering the topics that I've been on now and explaining how to work with it. But as I said, if you have any questions, just come to me and ask them. Thank you so much for listening. I hope it gave you something that you can take away and start